Okay. All right. So this is the theorem that the book doesn't have a proof for. So let's write the equivalent statement from the Bartle Sherbert book right beneath it, so we can kind of learn and compare, statements. It says
Belding, Mitchell to whatever.
Yeah, so we went from Belding, Mitchell, sorry for Mitchell,
Okay, so
Bartle, and Sherbet, as in that drink. And the theorem number is going to go down to 3.14. So actually I was saying, whoa, whoa. That is not a coincidence. As in the movie said, nothing is a coincidence.
No, it all adds up together. It's a conspiracy.
And the total is 7.2.7, which is the number for our class. We got the mathy humor down.
Yeah.
Yes, sir. Okay, so a sequence. So let's write it down here. Take that off. So we're looking at this. A sequence in R can have at most one limit. Okay. So what it does is, so this was a condition, and from this condition we said it has a limit, and we're dealing with the uppercase N, lowercase n, then there's the A, and we said there'll be only one A. And we drew the picture. Here, when you read this, what are the conditions?
The condition.
It converges.
Oh, okay.
Right? And what else? It's a sequence that converges to a number. It has a limit and it cannot have more than one limit. So this is, we have to prove this using our A's and uppercase N's and all of that. And what we're going to do is, of course, it's kind of like a direct proof, but it isn't. I don't know what to call this. Is this a proof by contradiction? I'm not sure. So let's start the proof. Proof. This is the result we want to show this. We want to show this result. And the condition is, the result and the condition are the same thing. I think that's the whole thing. Okay, all right. I don't know what I'm saying, so let's move on. Suppose we're going to suppose the opposite of what the statement of the theorem says. Suppose
Oh, so this contradiction.
it is, there are, so let's just put in by contradiction. Suppose there are two, suppose that, write the actual, that, sorry, A prime and A double prime are both limits of, and this is what they do. So this is their notation, Bartle's notation for a sequence. Limits of a sequence, round brackets, an in the middle.
Okay, sequence down, right, okay.
Yeah, okay, so now we're saying it has two limits, and if it has two limits, then what can we do with that? We can generate
Two clusters, what?
exactly two clusters. We can generate two uppercase n's.
Oh, yeah, two.
We can write out that stuff, and then we can use the triangle inequality to show that the distance between these two limits, which is absolute value, and inside you have the a plus b, is less than or equal to absolute value of a plus absolute value of b. Should we write those down here? Let's write them again.
I meant the first one, that's intuitive, that's, yeah.
So this one.
Yeah.
And there's a proof for that. We'll do that later.
Well,
Okay. It's an annoying proof, so that's why.
oh, is it?
Well, yeah, some proofs are more annoying than others.
Okay.
So this is a very nice one. It's very clean.
Yeah.
So, okay, so what's going to happen is we suppose this will allow us to generate some math, and then we will apply this on what we created.
Okay.
And when we do that, we manipulate that, we'll find out that the distance between the two limits is 0. Therefore, there's only one limit.
Yeah.
So the clustering is happening not around two limits, but only one limit. Okay, all right. So let's draw the picture here. Let's draw the picture up here. Let's keep the statement as long as possible. So we're proving this thing. So the picture for this is we got an A, we got a A2, and then we have two A prime and A double prime. And as this one singular sequence goes, some of its elements are going to cluster around this limit, and some of them are going to cluster around this limit, because that is our assumption. We believe that this is the case, which is of course the wrong case. So, and let's take our epsilon to be this value. Not a okay, yeah, all right, let's take this. So rather than going with this, let's divide it into two, because you can take any epsilon. So if epsilon was a positive number, we took a smaller positive number, and that allows us to, let's stick them on the line. And blue means that this number is not a term in the sequence.
Yeah,
So,
also the top.
yeah, you because it's the cut, yeah.
Do we never,
We never did the cuts and stuff.
that's right. But,
We can go back to it. Yeah.
we're never working with big ends anymore as like the thresholds. It's all gonna be epsilon now as our threshold.
No. Threshold is still big N.
Threshold's a big end. Okay,
I'm getting there.
you get it,
Yeah,
man,
okay. So,
I kind of went ahead. I was like,
yes,
right,
sir.
oh,
yes, sir. So we're gonna have A prime minus epsilon over 2 and A double prime. And last time, for half the class, I was calling it double apostrophes.
was not.
That brought shame to the whole classroom.
Yeah.
And nobody spoke up until I discovered the word prime in my head. Yes, sir. Okay, so
They don't want to.
yeah, they just didn't want to
Process.
embarrass me.
Mm.
So because it's clustering around two limits, we need two n's, uppercase n's. So let's take our first one here, our threshold n prime. So for the limit a prime, we're gonna have n prime. And for the limit a double prime, let's put that guy over here. And after this, some of the terms of this one single sequence start to cluster ANs. And some of the terms of the same sequence, after they hit this number, this n double prime is bigger than this. Okay, so n prime is, n double prime is, and therefore we don't care if the actual the real number here could be smaller than the real number here, or the other way
Oh, yeah,
around.
but-
That doesn't matter. Okay.
Is the term is
Yeah.
farther
So
along.
yeah, along the navigation gets
Oh,
us
the
there.
natural, yeah.
Yeah. Let's just call it the navigation. Yeah, the navigation gets us there. Wow, that's just good. Okay.
So,
Yeah, and then after this double prime, some of the terms of the sequence will start to cluster within epsilon divided by 2 of the second limit, a double prime.
wait, say that one more
So
time?
I'll repeat myself here again. So after we get to the index prime, n prime, to this term, the threshold term determined by n prime, a sub n prime, after this term, the terms of the sequence will start to cluster within delta over 2 of a prime, the limit a prime. After we hit a term in the sequence determined by the threshold natural number uppercase n double prime, this threshold term, after that all the terms will start to cluster around the a double prime within epsilon divided by 2
Okay,
distance.
I'm with you.
Okay, you're there? Okay,
Yeah.
very good. All right, so now let's write, so we kind of like went ahead and did the whole diagram because it's the next two lines of the proof that actually allows us to build that picture. So let's write the math after we build the picture already.
I like the picture first because
Okay.
now I know what we're.
Okay, okay, very good. So maybe I should remember that. For each epsilon greater than 0, so epsilon is a positive number, however small, and we've chosen a very small epsilon. There are, and it says there exists. This is one of those existence proofs.
Oh,
Yeah, it's the fancy word.
you even know.
There exists and double one single prime such that, what are we going to write here? Such that all the terms after this threshold term determined by all the terms an after
The threshold.
the
term,
threshold
they-
term determined by n prime
Mhm.
are going to be within epsilon over 2 within epsilon over 2 of the limit a prime. Yes, go ahead, for all n greater than or equal to uppercase M. Yes. Prime. It should be, oh, I have it completely wrong here. Yeah, it should be n prime.
Oh, yeah, is that?
I have an a prime over there.
Oh, that, I don't know.
That's really wrong.
So what's that
Mm.
so I got for each epsilon, every positive epsilon there exists in threshold prime, such that I don't get that middle part, that in the
This one?
yeah.
Oh, so this one is just saying, so all the terms an, and then this is the limit term, the distance between
Oh,
these two will always be,
less than, okay.
or in other words, if we had an interval.
You said that all absolute values should be taken distance. Yeah, you're right.
Yes, always. And there's nothing wrong with repeating that, because one forgets and then one gets into trouble.
All right.
Yeah, all the terms are going to be in here, ANs, including, because we have greater than or equal to AN uppercase. Okay, so I'm going to erase that. So notice something. We have epsilon here, but when we go and talk about the first limit a prime, our epsilon is half of that. Okay, so we say, hey, let's take a positive number, and the distance from which within which all the terms are going to gather will be half of that. And then in the book they didn't do this, but I'll do it, or I think they did this. And if for each epsilon there exists n double prime, there exists a threshold term. So now we're done with this one.
Yeah,
and we're doing the second one.
double prime.
Yes, double prime, such that this n uppercase n double prime will generate the threshold term, after which that threshold term and other terms of the sequence will start to gather, cluster around the second limit, a double prime, within this distance of epsilon divided by 2 for all n greater than or equal to n prime.
Double prime.
I mean, sorry, double prime. Very good. And n is the same n.
Yeah. Well,
Yeah, it'll be bigger n at this point.
yeah.
Yeah, it'll be, if n was 2 here, it'll be 3 here,
Yeah.
because we are further to the
So
right.
it's not the same.
Yeah, so the navigational numbers are increasing, but the real numbers, they can do whatever.
Yeah.
We don't care about that. We just want to navigate between the mess. Okay, all right. So notice before we move on that this distance here, this is just for us to notice, is epsilon between the two.
Ooh. Oh, yeah, that is okay.
Okay.
Oh, that's
Yes, sir. That's called trickery and deception and fraud.
well, I wasn't going all that far, but yeah.
Yeah. All right. So
You got
then,
any tricks up your sleeve.
yeah, always. Okay, not me, the guys who did this actually. Now I'm thinking, what should we do? Space-wise. We need to keep that diagram. You're gonna delete the,
The first one.
yes,
Yeah, that's
we
not.
don't need this anymore. We will also, this became this, so we can take this off. and you have it in your notebooks.
Yeah.
And if you're watching the video, you can always go back in time. Oh, it's just so good. Then, so this is the next step. I usually used to number them. That way you know where we are. Like for instance, this could be, this is one. On this page, this was the last thing we did. This is the next one. Okay. Then for n greater than or equal to n, no prime, no double prime.
Okay.
Actually, I messed up. That's why you're going, okay, let's go with this. And that helped me. Let n be greater than or equal to.
Okay.
No, your okay was still not good. Let n be the larger of the two, n prime and n double prime. That's what I wanted to write.
That one kind of makes sense.
Yeah.
Okay.
Okay,
In the real numbers.
in the natural numbers,
In the natural numbers.
this determines the first threshold term, after which all the terms of the sequence, some of the terms of, not all, some of the terms of sequence clustered around the first limit a prime. This is the index number that generates the n double uppercase n double prime that generates the second threshold term, after which, and including the threshold term, all the terms of the sequence, or some of the terms of the sequence gather around the second assumed limit, a double prime. And now we are saying, let's forget about these guys, or forget one of them. Let's let n be equal to the larger of them. And in our navigational chart here,
And they'll be n prime.
will be n prime. Very good. In our, let's write that. That's so good. In our navigational, this is just poetry, man. Chart, which is this thing here, n prime will be the
Double prime.
larger.
Yeah.
Double prime. And double prime will be the larger number. Natural. Okay. And we don't have to do any drawing. Let's just go ahead and then do. Then, if we assume that, then for n greater than and equal to our new. So actually, we need to make some changes. We're gonna disappear this guy. Okay. And we're just using this guy here, an. And so for all the terms after the larger threshold term, so this is all the terms after the larger threshold term. So let's write that. All the terms after the larger threshold, threshold term we apply. So we are going to apply the triangle inequality property. So in other words, what we're doing is we're going to only use one threshold term, and that is that thing.
Yeah.
Okay. It's this thing.
Yeah.
it's good to get it forever. Because it's gonna pop up everywhere. That little thing has saved mathematics from ruin. Okay. Okay, so. All right, so our agenda is to show that there's only one limit. And how do you say that in math? That the distance between those two limits is zero. So we want to show there is only one limit, let's say A. Okay, only one limit. How do we show that? We can show that by saying that the two limits that we assumed are the same. We can show that there is only one limit by showing that the two limits we assumed to exist, this guy and this guy, are the same. Now, when are they same? When the distance between them, when the distance between them is zero. Okay, so that's the thought process that's going on at this stage. So therefore, we're going to do this. We are going to say we want this thing A prime minus A double prime to be zero. So we're going to start with this guy here. So I'm deleting this. What I just wrote was beautiful. And you know what? I think I have not been recording anything. No, I have been. Okay,
Oh,
good.
yeah. Okay.
Yes.
You're good.
Yes, I'm good. I'm good. Okay.
Scaring us.
Well, I'm scaring myself. Even though I might never put it up online. So, all right. So our thinking went, if we are going to show that this was a bad idea, we just have to show that the distance between them is zero. And we're going to show that by bringing in this thing called the triangle inequality property. So our first step is this thing is equal to. So what can we do? We want to show that all the terms, we're going to take this and
Oh, I have a question.
yes, yes.
Since we have subtraction, right? Does that still work for subtraction? Would it be?
Oh no, for subtraction it's a different property.
Okay,
yeah. That's just for addition. Yeah. Subtraction, that would mean we're doing distance. And we are going to do distance here, but in a second.
Okay.
Okay, yeah. That's why you're going with where's the minus here?
Yeah.
Minus will be brought in. Yeah, okay.
I trust.
But what I'm thinking about is what we want to do is we want to bring in, we're talking about distances here. And I'm thinking how did the math people think here? Like, okay, we're thinking about the distance between these, but usually we think about the distance of the terms from these two guys.
Okay. Oh, you mean the A event, right?
Yeah, the A ends, right?
Yeah.
We don't usually think about when we write this, we're saying we want the distance between the two limits to be zero so that we can say that there's only one limit, A. But when we think about these guys, the first thing that comes to our head is the distance of the individual terms, A ends, from these limits. So why don't we just put those things in here? So let's do minus A end plus all the terms So all we did is we added all the terms in the sequence into this distance formula. And then we subtracted all the terms in the sequence from this so that this thing is still equal to this. So there's a trick going on, yes.
Okay, I don't know.
So now this is the step where we apply the inequality problem.
But A of n. So we're
Because when you have absolute values, the order doesn't matter.
it doesn't. But they're the same values for the two, even though one's associated with a double prime.
This is all the terms in the sequence. With
Oh,
the
regardless
negative
of the-
sign before.
Uh-huh.
This is all the terms of the sequence with positive signs before.
Okay.
They will cancel each other
Yeah,
out.
and then it'd be equivalent. Okay,
Yeah.
I got you.
Yeah, okay. Very good. Yes,
Yeah.
keep asking me.
So we added them, and that helps us because
We didn't do anything. We
No.
added and subtracted.
yeah, the
We
same
did,
value.
we did.
We added 0 to our
Yeah,
Problem.
we did niche. There's a term, the word I forget. We did zilch.
0. Got you. No.
Oh, okay,
Yeah.
all right. So all we did is we could put some comments, adding and subtracting
And
the terms, all the terms of the sequence. Okay, next, we're gonna do this. We're going to apply inequality, triangle inequality property to this line here. So this guy is less than or equal to so how do we go? This A here, this whole thing is A. And this whole thing here is B. I'm pretending you're not a science major.
yeah, explain.
Yeah. And therefore, we can go from here, this becomes this, and this becomes this, and there's a plus in between. So this plus falls down here. Okay, now usually when we do this, this is the form. And this should be double prime.
Yeah.
Usually the form is this. You have the terms first and then minus the limit. But this is the same thing. This, so let's focus on this for a second. This thing is the same as whatever the result of this is, you take the absolute value and you get a positive distance.
Oh,
Whatever the
Yeah.
result of this is, you take the absolute value and get a positive
Yeah.
distance. And those two distances are identical. Therefore,
it doesn't matter.
therefore we can do this. Good, okay. Next, what's the value of this thing? And we erased that, sorry. It was, this thing,
Is it epsilon?
all the distances that we calculate here will be, yes, epsilon divided by 2.
Oh, yeah.
So this thing is epsilon divided by 2. And this thing is epsilon divided by 2 because those are the lines we wrote out. So I'm just putting these two guys there. I'll put a plus between them. And I'm going to say that the sum of these two guys will always be less than the sum of these two guys. Exactly. So let's go back up. If you look here, this guy is not included in the interval. Let's write the interval here. A minus A plus. These two numbers are not there. This number plus this number, what am I saying here? Yes, okay. Any distance that this thing calculates is going to be smaller than this.
Yes. Or it's not equal to, or just smaller?
Oh, no, oh, okay, sorry, yeah, so. Any distance that this will generate will be less than this distance.
Okay, yeah.
So because it will be within the epsilon divided by 2. Any distance that this thing generates, will always be smaller than this. Any distance that this thing generates will always be smaller than epsilon divided by 2. Therefore, we can put this less than and we can drop the negative.
Okay.
Because yeah, they equal to. Because what, yeah, not negative, equal to, because this is what we want. If you have this formulation at the end of all your math, that means there is only one limit and limit exists. Because the definition of the limit is this thing for sequences.
Oh.
Remember all that business?
Okay, wait, hold.
So we want to get to this. Epsilon over 2 is not good enough. We want epsilon over 2 to become just epsilon, which happens right
Yeah,
here.
because the two are.
These two guys are equal to
And
it.
that's why you made them, okay. Oh.
That's why I made them smaller.
So yeah.
Yeah, because in the end, it needs to be at least epsilon. Because this is the form that you want to prove that there is one limit that exists. Okay. Okay, so now we got that. What does this mean? This is equal to here, right? This thing, we can ignore this. This is actually saying epsilon. And what's here on this side?
Yeah.
It is
A prime plus A double prime.
because actually we don't actually want that, but we want to, sorry, ignore all that. Let's get back. Now what does this say? This says that a positive number
Minus
is less than epsilon.
Oh, and
Now we apply the smallest.
Yeah, so that has to be 0.
Yeah.
Oh.
This
Okay.
this implies that a double prime equals 0. Because we know that a double prime is a bigger number. No, sorry. Wait a second. Yeah, this is.
Let me see. Show the.
Oh shit! Why does this work?
Well, we made our n because let n be the large of the two n prime and double prime.
Yeah.
So that's why a double prime is bigger.
Well, I'm just going when we do the equals to 0. Do we wait or oh okay? I guess we solve for it. And this is a positive number. No.
What's wait.
Well, what I wanted to do was this. Oh no, this is fine. Sorry. Okay. If you did this.
Yeah. Okay.
We can do that, right? When we do that.
Wait, can we?
Kind of. And I might be wrong about this. When I take the absolute signs off, this stops being a distance.
Yeah.
It becomes one number minus the other number. So I just took off the.
But we're trying to prove that the distance is 0, right?
And then this implies we've already proven that it's 0. Where did we do that? It's this thing says that this thing is equal to 0.
Okay.
And so we go here, we go this thing is equal to 0, but this is a positive number. Because it's a positive number, or if we take it off, then this indicates that a prime equals, I think there's some missing math business that limits are saying. So we need to think about this a little bit because I might be messing up right at the end of this has been, and I think maybe we'll do this. The first thing we'll do next Saturday
Okay.
is look at this thing. What do you think, Jake? Yes? because we do have some issues here.
Yeah, that sounds good.
Can we go from, right, can we go from this side to that?
I don't think so. Because
Can we go from absolute value? Because usually you can go from something that's positive, you can put absolute signs on it.
okay, yeah,
If something is positive, you can put the bars. Can you do the opposite? Can you take off the bars? If you do, then you're not thinking in terms of distance.
mhm.
You're thinking in terms of one number minus the other, which in this case equals 0. Sorry, it's an equation here.
Because
Yeah,
I think,
hey, sorry, fix this in your, so it's a 0, and then this implies,
yeah, they both equal zero. Yeah,
you probably got it right, I messed that up, yeah.
yeah, because I think the 0 is the one that's helping us out.
Yeah.
If this was a
Because
prime minus a double
thing,
prime,
this is actually saying this. This is the
Yeah.
whole thing.
I mean, actually, I'm gonna. That's a good point, just to make sure. Don't want to forget.
And because of this, we are allowed to say that this equals 0,
Because that theorem,
and then because of that theorem.
and like an absolute.
And then
value-
here is the tricky point. Can we take off these things?
I think because it's 0.
Yeah, we could Google this.
Yeah.
Oh, whoa.
You said we had to do 2 proofs, right?
We could, yeah, we could do another
No,
one.
we said do 2 definitions.
We did 2 definitions, 1 proof.
Yeah, 1 proof.
Yeah, we can do one more. We could take a lunch break and then we can do another one. So that's something like we could eat something else too. Thai food, you wanna eat that?
Oh no, I'm good. I'm gonna cook some of that at home. Probably.
What do you have at home?
I got mac and cheese.
Shit. Okay, 1 second. I'm gonna see, I'm asking the internet.
Yeah, you know,
Can
he won't
we-
lie to you.
Take absolute value bars off. Oh. Yeah, you can't just take it off. Wait a second. Oh yeah, you can.
What?
Yes, you can. Okay. So the trick is, I forgot about using the definition of absolute value. Yeah, let's do that. So what happens is, if you have this, we have a number inside it, right? If this number is negative, then this thing is equal to minus. If this number is, in our case, it's a negative number. So you want to write this down. I just figured it all out. God bless you.
Okay. Yeah.
So we're using the definition. We're applying the definition of absolute value. Apply. Okay.
My definition.
Okay. If what is inside, which is a prime minus a double prime, is a negative number, which is our case,
Yeah.
then when we
Wait. A prime minus a double prime is a negative number?
because a prime is smaller than a double prime. If you look at
Oh,
the
yeah.
navigational chart, according to our navigational, our picture that we're using to ground ourselves in reality.
Yeah.
Whoa, that's even deeper. I mean,
You really are a poet.
yes, sir. So so we have a minus here.
Mhm.
Let's okay. What does the minus do? The minus goes in, makes this, goes in, and now we can write this as this.
Okay, yeah.
So now this is a positive number. Because a double prime is bigger than a prime. Now let's look at the other case, which doesn't apply to us, by the way.
No.
This is the only case that applies. If negative, then put a negative sign here. If this was positive, which is not this is not our case. then we just write this again. And when we do that, we can't even say that because we know this is a case that we put a plus here. We can't do this because we know this number is a negative. So this is the only case. So the definition says if A is negative, then put,
Okay, yeah.
if A is positive, don't do anything. Because A prime minus A double prime is negative, we do this and we find out this is the positive number that, so this is the positive number that goes between epsilon and greater than or equal to 0. This thing here. And this leads us to A double prime minus A equals 0, which implies that A double prime equals A prime, which implies that the limit is unique.
Yeah.
By contradiction.
What's that?
Yes. Because that's a serious issue there. You can't, when we're doing math at this level, we can't just,
No.
because we need to be clear, crystal clear about every step, because it's going to bite us later on.
Oh God, I didn't even.
Yeah. So always remember, in this class, go by definition. If you get confused, remember the definition, which is this, and apply the definition and see where it takes you. And because our navigational chart said that A double prime is a bigger number, and because of the ordering here, we ran into trouble and confusion. And I was just, so last time those two guys did not stop. Jake, we super good?
Yeah.
Okay, all right, so we're gonna end the session right now. And then we need to eat something. And my daughter is here too, she's probably hungry, or are you good with that shit?
I might be good at this, but
Yeah, okay, let's think about this because I'm having guilt, Jake. So I'll call you if you have a second session to this afternoon, okay?
Okay.
Otherwise, this is where we stopped last time.
Yeah.
So when our next session is going to start with the next set of related proofs.
okay.
And there she is. She's running off. Here she comes. So Adya, what's going on? Oh, you forgot to record? Yeah. Okay, so so you can take off and you have the key to the house, right? Yes. And this is Tristan. This is Athiya.
Here.
Yeah. Okay. All right. Mr. Jake, I'll call you like maybe in half an hour. If I don't, I'll see you next week.
All right.
And I'll call you on the phone tomorrow.
Okay, sounds good.
All right. Okay. All righty. Did you enjoy it? Was today clearer than last time?
Yeah, today was good. I liked it.
Shit, today was better than last time. Okay. All right. Thank you, Jake. I'll talk to you tomorrow for sure. Okay.
All right, talk to you then. Bye.
Bye.
So,
Let's do this.